Hello, good morning everybody, or good afternoon, whatever time you're watching this video. Say just the reason I'm staying home today is because my daughter has pink eye, so yay for me. Alrighty, let's get down to physics though. Alright, here's our worksheet one that we're going to be using. So you have a printed copy of it because I wanted to make sure that you were able to write down this example as I was talking about it. Alright, so for this very first one, it says to make a well-labeled diagram of our situation. So, first thing, we have a little cliff, right? We have a person standing up at the top, and it tells us that he's throwing a ball and straight downward. It gives us our initial velocity, and it tells us that's 20 meters per second. So essentially, that's all the information we have for part A. So that's fine for our well-labeled diagram of our situation. For part B is asking us to just write down the quantities that we want to find and the quantities that we actually have. First thing we know that our initial velocity is 20 meters per second. That was something that we were given in the problem. The second thing that we know for this one, we know our acceleration. Because anytime a ball is traveling down to the ground, it's being pulled down by gravity. So in this case, our gravity is 9.8 meters per second squared. Alright, other information that we don't know, but we might have to solve for, we might have to find a velocity final, possibly a time, and a distance of how far did this ball travel to the ground. So those are sort of the things that we might have to solve for in this case. So, moving downward then. The acceleration for this one is what we just wrote down right up here. So we can take that and say that our acceleration then is equal to our 9.8 meters per second squared. For the next part, for part B, it asks us to calculate the displacement during the first 4 seconds. Alright, so I'm going to go back up to the top, and I'm going to write down up here just sort of some helpful equations to use during this worksheet. So either, if you couldn't find a note card, whatever it might be. So our first one is if we have a constant velocity, we can take velocity times time and get a distance. So this is only when our velocity is constant. So don't use this one unless we have constant velocity. Another equation that's going to be useful is we can take velocity divided by time and get our acceleration. This is one that we might want to use in case of velocity changing. Then we have an equation that requires no time. So just in case, we want to solve for any part of this equation, there's no time involved in it. So it's just the final squared minus the initial squared is equal to 2 times acceleration times your distance that you've traveled. We do have one other equation to solve for distance. It's our 1/2 at squared plus b initial times t. So those are sort of our 4 helpful equations that we're going to use to help do this worksheet. Alright, so for this first one, part B, calculate the displacement during the first 4 seconds. Well, we have an equation up at the top, which is our delta x equals 1/2 at squared plus b initial times t. That's the one we're going to use for this equation. Because if we look at the list of items that we have velocity initial, we have acceleration, and in the problem, we're given time. So we have all the things we need to actually solve our equation. So now it's just a matter of plugging them in. So our 1/2 times 9.8 times our given time of 4 seconds squared plus is our time of 4. So when we do this math, we set everything up, we should get a distance of 158 meters. Alright, for our next problem, we want to calculate the time required to reach a speed of 50 meters per second. Think of 50 meters per second as your final velocity, because that's what it wants to know. How long is it going to take it to go to 50? So for this problem, we have an initial velocity of 20 meters per second. We have a final velocity of 50 meters per second. And we know our acceleration because the thing that's making this go faster is our 9.8. So what we want to solve for is our time. So if you take a look back at the equations up at the top, right, knowing the variables we have, which one of those equations would you like to use? Right, so scroll back down, and let's go ahead and write that equation then next to our problem. So hopefully you pick that one in your head. So all we want to do then is rearrange this equation and solve for time. So we're going to have time is equal to our velocities over our acceleration. So remember, we can always break apart the velocity into its final minus its initial. And then we're going to divide by our 9.8. So our time then for part B should come out to be 3.1 seconds. For the last part, part F, calculate the time required to fall 300 meters. We do have to use the quadratic formula. So I know most of you have graphing calculators, which you can just plug in the numbers. I'm going to put down over to the side the quadratic, how to solve for it, just in case you did forget how to do that. So it's negative b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a. So I put that there just in case, you need to actually use the math part of it. So I'm going to work through this problem as if I have a graphing calculator. So when I get to the part to use this quadratic formula, I'm going to just give you the answer of what the time is. Okay? So for first one, calculating the time required to fall. So if we go back up to the top, right, and let's look at our list of equations. So we want to calculate time that it takes to fall. All right, we have an initial velocity, we have an acceleration, and we are given a distance in the problem. So take a second, look at those equations, and let's pick out the one that would be most useful for us to solve for this problem. So hopefully you got this one, 1/2 at squared plus our v initial times t. So for this one, for our delta x, it gives us in the problem that this is 300. So we're going to say 300 is equal to our 1/2 times our gravity, that's our acceleration. Our time we don't know, that's what we were trying to solve for. We do know that this thing had an initial velocity of 20 and t. So if we put this into the formula of quadratic, this 300, we would move over to the other side. So we're going to get 4.9 t squared plus 20t minus 300. So again, this is the part where I'm going to plug it into the calculator, but if you do need to, you can always use this equation to help you solve for it. When we get to it, if you have to use this equation, always pick the plus sign, because the plus sign will actually give you a positive number for time. If you use the negative sign, you're going to get a negative number for time, and we can't really go backwards in time. We can only go forward. So after that, Once we've worked through it then, our time should come out to be 6.0 seconds is how long it's going to take for that object to fall those 300 meters. The very last one then, calculate the speed after falling 100 meters. Sorry, a little tickle in my throat. Alright, so calculating our speed. Think of this speed, it wants to know speed after. So think of this as it wants to know how fast is it going after it's fallen 100 meters. So we know from our given other problems that we have a velocity initial of 20. We have a final velocity we're trying to solve for. And we have a distance. So we have a final velocity, an initial velocity, and we have a distance. So we're just taking a glance up there to see which one of our equations would be most useful. So we want to know the speed. So hopefully you picked this one, the v final squared minus v initial squared equals 2 times a times our height. So this one, we don't need time because all we want to know is the speed that it will take to travel that 100 meters. So if we rearrange our equation then, right, v final squared is equal to 2 times our 9.8 times 100 plus our initial velocity was 20, and we have to square that for this one. So after all math and rearranging, of course we want to take the square root of this whole thing because that will help us get rid of that squared value. So our velocity final should come out to be 49 meters per second. Alright, so you have then 2 more problems. Hopefully working through this first one will kind of help you see how we've used these equations again. Because I know it's been a little while since we've used some of these equations. But again, on the top of your worksheet, write down those helpful equations and just think about what variables I have and how I can plug them into these problems. Alright, I will be back tomorrow, so good luck, and hopefully you guys can get all these problems done in class. And so we'll get to look at our worksheet tomorrow and, see how you did. Alright, so see you tomorrow. Bye-bye.